back. So now we can use derivative of sine to find derivative of x squared times sine. What do? We use product rule. Derivative of sine is cosine. Derivative of x squared is 2x. That's all. So derivative of y is, take derivative of 1 at a time. You get x squared cosine x plus sine x 2x. Okay. Now, using the methods that we used for finding derivative of sine, you can find derivative of cosine. Derivative of cosine is negative sine. Now you can use quotient rule for tan, sine over cosine. Okay. Using quotient rule, you can check this work. Derivative of tan is secant squared. Okay. The derivatives of the remaining trigonometric functions, cosecant, secant, and cotan, can also be used using quotient rule. Eventually, we get a list of derivatives. Derivative of sine, cosine. Derivative of cosine, negative sine. Derivative of tan, secant squared. Derivative of cosecant, negative cosecant, cotan. Derivative of secant, secant tan. Derivative of cotan, negative cosecant squared. So you might see a pattern here. Secant and cosecant, the outcomes look similar. Tan and cotan, the outcomes look similar, right? So one of the things to notice is every co-function has derivative negative. Okay, every co-function has negative derivative. All right, keep that in mind. It will be easier to remember. Now, trigonometric functions are often used in modeling real-world phenomena. In particular, vibrations, waves, elastic motions, and other quantities that vary in a periodic manner can be described using trigonometric functions. In the next example, we discuss an instance of simple harmonic motion. All right, an object at the end of a vertical spring is stretched to 4 centimeters beyond its rest position and released at time t equals 0. So you pull it down and release it at time t equals 0. Okay, its position, that is, this will go up and down, right? So the position is given by this function. S is ft, 4 cosine t. Find the velocity and acceleration. Okay, what is velocity? Derivative of position. So it comes to negative 4 sine t. What is acceleration? Derivative of velocity. So derivative of negative 4 sine t, which is negative 4 cosine t. So how do we analyze this? The object oscillates between negative, for s equals 4 to highest point s equals negative 4. Okay, so that's the oscillation. The period of oscillation is 2 pi, which is the period for cosine t. Okay, velocity is 4 sine t. Where is s? S is the one in blue. Oh, that's the one in, S is the one in pink. That's correct, of course. So it starts at 4 and continues. Velocity and acceleration. All right. So the speed is absolute value of velocity, which is 4 times absolute value of sine, which is the greatest when sine is 1. That is when cosine is 0. So the object moves fastest as it passes through its equilibrium position. Okay, and its speed is 0 when sine t is 0 at its high and low points. Acceleration is negative 4 cosine t when s is 0. It has the greatest magnitude at high and low points. See the graph. All right. So if you're a student of physics, this will interest you quite a bit. Okay. All right then, guys. Next videos will begin on problems from web work. Until then, bye.